Hello and welcome to Interconnected, the podcast that explores the intricate links between life's most profound, weird and wonderful things. I'm Jake Robinson.
And I'm Robin Taylor.
And in each episode we discuss an interesting science topic and challenge ourselves to connect it with another subject that might seem completely unrelated, sometimes trivial or quirky.
Exactly. Think, Jake, about bitumen and cryopreservation, or even termites and cultural revolutions.
So we hope you find the podcast thought-provoking and entertaining and invite you to explore the interconnectedness of life.
So come on then, let's get on with the show.
Let's do it. So before we jump into today's main topic, it's time for the neck of the woods. And in this section, we each take 30 seconds to share what's happening in our part of the world. So over to you, Robin. What's going on in Fiji?
Well, I guess probably apart from things like weather and blah, blah, blah and politics. But our big issue was mainly that we had two big rugby teams play actually in Fiji, which is always big. So we had the Drua and the New Zealand Hurricanes. So that's caused, and that was a bit of kerfuffle. But given that we're a rugby mad nation, it was the big event.
Yeah, right. Is that rugby union, I guess?
Yes, correct. Yeah. 15s.
Okay. Who won?
We lost, as in Fiji lost.
Shame.
There's going to be some lynching. I'm not sure who, probably me. As the saying goes, it'll end in tears and it's probably me.
Well, not much happening in Australia, so it's moving out of the summer now, so it's getting a bit chilly, must be 15 degrees Celsius or something. And so I've just typed in what's new in Australia, and apparently there's something called the Devil Comet. I don't know if you know about this. So you can see the Devil Comet in Australia before it disappears for 70 years. So it orbits every 71 years and is about to reach its peak blindness. So if you want to see a comet, come to Australia. I assume you can see it where you are as well. The Devil Comet is a periodic comet named 12P Pons Brooks. I thought it was named the Devil Comet. Anyway.
Astronomers. There's no holding them to account.
All right, shall we get on with the main part of the show? So what's the main topic today, Robin?
So we're going to be talking about nanotechnology, and maybe over to you, Jake. Can you get it in a nutshell?
I'll try my best. So nanotechnology is the science, engineering and manipulation of materials at the nanoscale. So this typically involves dimensions that are less than 100 nanometers. And you can think of this as 0.0001 centimeters, which is about 10 times smaller than a bacterium. So really, really small things. So at this scale, materials exhibit unique physical, chemical, and biological properties that differ from their bulk counterparts. So nanotechnology involves the design, fabrication, and characterization and application of nanomaterials and nanostructures for various purposes across different fields, for example, in electronics or medicine. So it enables precise control and manipulation of matter at the atomic or molecular level, allowing scientists and engineers to create materials with tailored properties and functionalities. Some common techniques in nanotechnology include nanolithography. So this is a technique used to create patterns and structures at the nanoscale, so really tiny scales again. Chemical vapor deposition as well. And so these are super thin layers of films that are kind of coated on microelectronics. Yeah, so that's nanotechnology in a nutshell. So let's have a back and forth convo. What would you like to talk about in relation to nanotechnology today?
So I think for me, the nanotechnology that I think about a little bit here is how it could be applied in health, but also how it could be applied in warfare. And it's almost like the same aspects. In one very simple case, you could have nanotechnology that can really be these small machines that are going around and potentially mimicking some of the things that we could have in our own immune system. So that comes around to a previous podcast where we're talking about biomimicry. And you could actually have things where targeting individual cells. And so you could have something where you could have very clever aspirations to maybe target cancer cells or repair things such as Parkinson's, or look at Alzheimer's, or these sort of chronic conditions that some people have, and that it could be fixed by nanotechnology. But in the same way, you could also imagine some terrible scenario where people, build the nanotechnology to do precisely the opposite, where they're actually going to impair, they're going to give us those things.
So they use nanotechnology to target our cells in nefarious ways.
Right. And it could be, some of the science fiction stuff could be just to make us infertile, say. It could be very subtle and very clever, and we wouldn't know about it. And you only have to look at statistical things where it wouldn't be immediately obvious that an attack had occurred. It can occur in a very targeted way, because the nanotechnology could be potentially dialed in so cleverly. And I think the thing that also worries me a little bit, so aside from the ethical concerns that could be there, because one of the areas that has been looked at quite a bit is, or looking at, is regeneration. So basically people looking for elixirs of youth and stuff like that. I think that's going to be something that will potentially cause some moral and ethical obligations for us to kind of go through. In other words, what does it mean?
Because it's already in, like nanoparticles are already in lots of healthcare products, aren't they? You know, like face creams and probably toothpaste and whatever.
Yeah, but they're not at the point where, you know, I think the issue that nanotech is trying to figure out right now is trying to figure out how to not just do self-organization or to try and do things which allows something to be targeted, like you were talking about the lithography, the nanolithography, but where they could actually derive power from their surrounding environment and actually start to be mobile and move around. And then, God forbid, we get something which is autonomous AI and nanotech put together.
Sounds like a nightmare. Should we just talk about some of the positive things a bit first, though? So you mentioned like drug delivery. Maybe we should talk a little bit about that, how that happens. So
I think absolutely. I think it's one of those things that let's go, as you say, on the positives, and then try and figure out.
And then we'll come back to the the sci-fi after. So I know that in nanotechnology, in terms of drug delivery, there's things called liposomes or liposomes, and these are like spherical vesicles composed of lipids. So these are fats essentially, a lipid bilayer, and they can encapsulate hydrophobic drugs with their lipid core. So these drugs are basically contained in the center of these kind of vesicles, and so this is how they're delivered into people who have cancer, for instance. So there's one drug, I'm not going to name it because it's branded, but it's a liposomal or liposomal formulation of the chemotherapy drug doxorubicin. And so liposomes, keep saying it. How do you pronounce it? Do you say liposomes?
I say liposomes, and I say vesicles.
It's weird because I say lipid, but I probably say liposomes. Okay. So the liposomes encapsulated in doxorubicin, protecting it from degradation and minimize its interaction with healthy tissues. And I think this is one of the core benefits, because usually if you inoculate someone with drugs, then can kind of have a non-targeted effect where it's damaging other tissues. So the surface of the liposome is modified with what's called a polyethylene glycol, which reduces recognition and clearance by the immune system as well. So this is important as well. So we're actually able to inoculate a kind of foreign substance into the body and prevent the immune system from overreacting by coating it with some kind of nanoparticles. Once it actually targets and reaches the tumor cell, then it can release its drugs and have its beneficial effects or adverse effects on the actual tumor cell.
Right.
So it's pretty important and cool stuff, isn't it?
Yeah.
Impressive.
I mean, I think, yes. I mean, it's also being used or suggested that it could be used for actual diagnostics as well. So actually trying to figure out, so you're looking for really small stuff that's there. So I was reading about something which was using magnetic nanoparticles combined with MRI. So you can kind of really get down to really small sections of that. And I guess it's always that thing where if you can detect something early on and, target it, even if it's a gross thing, but it's, you're taking out a centimeter of material rather than maybe through keyhole surgery, rather than waiting until it's detected and now you have to take out 10 centimeters. Amazing stuff that definitely could be done for that. And I think also that idea of, these degenerative diseases which, would seem to attack the whole body at the same time. And obviously cancer is one of them, but these things like multiple sclerosis or Parkinson's or Alzheimer's, and there's sort of, there's an onset on it. And for the moment, we seem to just sort of be at the point of only being able to manage. So you kind of like, you're going to arrest where you are at the moment or delay the inevitable. But nanotechnology has the promise of actually beginning to reverse that it could actually go in there and sort of be like small machines that actually are able to make connections, start to get systems firing again and start to regenerate the stuff again. So I mean, that combined with stem cell technology seems to be very promising.
It's pretty insane how we're able to work with such precision, even though, like I said before, the things you're talking about is 10 times smaller than a bacterium. Incredibly small things.
Yes, I mean, I think the first time I came across it was probably about 15 years ago where, I mean, I don't know how old it was from there, but looking something in the Scientific American magazine and seeing someone, I think it could have been an IBM, I can't remember exactly where it was, some high-powered lab, and they're basically writing names with individual atoms. They're actually kind of
Yeah.
writing,
Wow.
using carbon to write out, logos and names. And I mean, to be able to move atoms around to that precision
With that
just
precision,
seems
yeah.
extraordinary. Yeah?
Mm.
I think the thing that I definitely wanted to make a bit of a connection as well is just, I think what is really fascinating about it as well is just that the physics of dealing in that scale is so different from our scale, isn't it? I mean,
Yes.
suddenly viscosity becomes a real issue, but gravity disappears
Yeah.
more or less. It's not, it
Yeah,
doesn't exist.
exactly.
But yeah, the viscosity of
Have
straightforward
you
liquids. I think that, certainly the other thing that is really extraordinary about the nanotechnology, which although I did focus on the medical side, which is
Yeah.
there, but just because the physics is different, just the fact that we could start to get to aspects where we're looking almost at superconductivity at room temperature, and that we're able to kind of figure out how that could or might not work again with these nanotech coatings. That does seem really extraordinary, where we could have
Yeah.
integrated circuits or something electronic going which is using minuscule amounts of power and yet doing today's performance. Yeah, I mean, that all sounds super exciting, doesn't it?
Yeah, it does. And just the kind of, yeah, so like carbon nanotubes, it's like
Balls.
incredibly strong materials that are
Yeah.
incredibly light, and like the mass is incredibly low, but they're super strong. That has a lot of promise as well, doesn't it?
Yeah, yeah. So that does definitely tie in with this idea of the biomimicry that we were
Yeah.
speaking about before, where the nanotech can be used at that molecular and atomic scale to actually
Yeah.
build things that, for whatever reason, nature is not able to provide at the moment in a way that suits us. It's already being done in a way. Yeah. So the promise of it is, and so I think
Mm.
that maybe segues into this idea of we can't ignore it. The
Yeah.
potential gains from it are just enormous. I mean, literally life changing
Mm.
on so many different scales. So, yeah, it
Mm.
would be crazy not to be looking into this.
Sure. So should we talk about the crazy sci-fi things going
Yeah,
wrong
I was going to
kind
say,
of
but,
perspective? Bum,
but,
bum, bum. Everyone's
yeah, there's
waiting
always
for a
a but.
but, aren't they? They're like, yeah, okay, get
Yeah,
over with the positive
yeah.
stuff. Right. So, what could possibly go wrong, Robin, with nanotechnology?
Well, I think that I spoke about it at the beginning, but just this idea about just as it can help for health, we can actually,
Yeah.
be really horrible and target our
Yeah.
perceived enemies, whether it's other humans or whether it's animal species, but just the ability
Yeah.
to, again, we spoke about things that are so small, it would be very hard to detect using our
Mm.
conventional sensors that we have at the moment, and that gets sprayed around. It can be an aerosol, or it could be
Mm.
just a contact thing that goes onto there. It could be something that has properties like a virus, or it could be self-replicating.
Mm.
It could take energy
We should
from.
probably emphasize that this is like sci-fi speculation at the minute. Like, we're not. It's potentially possible, but we don't want to, start the next conspiracy.
That's correct. That is
Yes.
correct. One of the things that we need to look at is these things, as you correctly say, are not here at the moment, but
Yeah.
it's inevitable that once we get really successful with doing the really nice stuff, someone's going to figure out, hey, we can flip this around and do really horrible stuff as well.
Sure,
And I think
especially
that,
when it's combined with AI.
right. And then just to make things even worse is when you, let's say, have autonomous AI, which is,
Yeah.
again, something inevitable that we're going to be heading towards. So, in other words, there's no necessary human intervention, but you just kind of set up parameter that could be as loose
Ooh,
as
it's crazy
go
to
out
think
and do
about.
stuff.
Yeah. You could almost see these like nano computers that are made, like some kind of computer at a nano scale that then
Yeah.
is AI integrated within the computers. So then the AI is actually able to do the self-replication of the
Yeah,
nanotechnology.
there could be
Mind blowing.
so many things that are going. I mean, again, we're learning just to kind of put a weird link in there, even though we're not there at the moment. But I'm kind of fascinated at the moment in drone technology, aerial drones. But the fact that we've actually got the computing power to have drone swarms
Yes.
do these really complex artistic displays.
Mm.
I don't know if you've
Yeah,
seen
that's
YouTube
impressive,
videos
isn't
of,
it? Yeah, yeah.
yeah.
I find them quite interesting to be used in forests. So you can have like drone swarms. So they have object recognition, so they don't bump into trees and things. So you can do
Yeah.
like a quite efficient forest survey.
Right. But, well, I guess my point is that our existing computing power on conventional silicon power is already strong enough to be able to control a whole swarm of drones into
Yeah.
really, really intricate patterns.
Hmm.
And then combine that with AI, and then you start thinking,
What could
okay,
possibly go
lovely.
wrong?
Yeah, that's right. Yeah, we've always succeeded with this kind of stuff before. So yeah. So I guess that what I'm trying to say is that let's go back to that thing about where you can see how this could be very nightmarish scenarios that could be if it does go wrong. So in which case we're back to the idea of
Yes.
trying to figure out how do we prepare for this? And the potential gains are so great that we'd be foolish not to explore it, but the dangers are also so great that we probably sorry, we should say what could possibly go wrong. Not just in terms of deliberately trying to do nasty things,
Sure.
but what about accidental things where
Yeah.
suddenly we destroy a whole ecosystem because we were trying to develop a medicine and then it turned out it was really bad for this particular plant or this particular species and all that sort of stuff. And then
Going
how
back
do
to
we get control of it?
the vulture episode where we gave a particular anti-inflammatory drug to livestock, but then we didn't actually know that it was highly lethal to vultures.
Yeah, absolutely. So
Could have
just
a similar
complete.
scenario. Should we just briefly talk about, you said the potential gains or benefits are so extraordinary that we'd be foolish to not explore this technology? But some people might disagree with that. Are the gains that extraordinary? If you had cancer, you would say, hell yes.
And also, more to the point is, I mean, maybe let's take something like emphysema.
Yeah.
So it's where your lungs are slowly being dissolved from the inside out, as it were. I mean, that is a very horrible, painful death.
Sure.
And there seems to be very little that you can. There are some potential stuff that's going on there, but if you have a friend who's in front of you and is slowly dying away from emphysema,
yes,
yeah, why would you?
Exactly, yeah, that's my point. So if people have these diseases, or if you have it, or if you know somebody that has these diseases, then you're obviously going to say,
yeah,
we should be exploring whatever we can in order to.
I think that's maybe
them.
the issue to talk about is just it's to do with quality of life, isn't it? I mean, we're looking at something that could be a massive quality of it. It's not like it's, okay, let's invent a technology such as a smartphone and then all our kids can get depressed by looking at social media and, like it's a negative from that point of view. And we're talking about actually someone who's going to have, I mean, again, if you had Alzheimer's and you watch, I find it really heart-rending to listen to people on radio programs where you've got a couple and they're in their 80s and he is now looking after her and she doesn't recognize him anymore.
Yeah.
And that's the person that he fell in love with and he married and they had wonderful times together. But now he's just basically the carer. And she's
it's
like
incredibly
almost
sad.
Yeah,
But it's there is an argument as well to say that because we're keeping ourselves alive for so long, then Alzheimer's is obviously increasing when evolutionarily we'd probably already be dead. As morbid as that sounds.
But I also think
that may be another episode. Should we be keeping ourselves alive for longer than we naturally would be?
That's why I was mentioning before that there are real moral and ethical issues.
Yeah.
That we definitely do need to look at that and, how would that work? And I guess for me, what I'm angling towards eventually is, yes, I think it's right that we should be questioning those things. Like, are the benefits that great?
Yeah.
And I think that's the moral and ethical issues that we need to look at.
Sure.
Dare I say it, there may be quite a lot of free will involved here to try and
yes, maybe.
try and
I reckon the majority of people would be pro, A, staying alive for as long as possible, as long as they were healthy, and B, not wanting any harm on other people or wanting, they'd want people to be cured of cancer. I think the majority of people would want that, wouldn't they? So.
And also, don't we also want to have things where not just our health, but we could apply it to, maybe endangered species that are on the critical list of just, wouldn't we also want it for things where we could say, well, you know what, in terms of we're in an environment in which climate change is a reality.
Yeah.
And, we can actually now start to use far less energy. Like we're looking at, I don't know, I'm just guessing here, but let's say a 20th of the energy that we need to continue our lifestyle that we're doing. We don't have to,
as long as it doesn't have these negative consequences.
Right. So when you're talking about, let's say, potential gains, I mean, that's why I'm saying these are definitely things that we need to look at, but it would be hard to argue against many of the benefits that people are projecting.
Yeah.
But I guess what I'm angling towards is that we're back into this idea of right now we've got an opportunity because as you pointed out, it is science fiction, the sort of nightmare scenarios that we're looking at the moment.
Mm.
But why wouldn't we then spend a bit of time trying to figure out, okay, well, how can we prevent against that? And I guess that's where we need to think about, okay, how do we get together and start to put in policies and processes in place?
Yes.
Let me give you
the same with AI. We need all these policies and regulations in place now, really, don't we?
Yeah, we need to start talking about it now. We definitely need to start talking about it now so that we can anticipate it.
All right, so we move on to the next part of the show, or did you want to talk about anything else on nanotechnology?
No, I think I'm done.
Cool.
So, Jake, would you have an ability to do a weird link between nanotech and something that's very unusual?
That is a good question, Robin. I'm not sure it's weird. It might be, but see what you think. So, my linking topic is future grain production.
Grain as in wheat and oats
grain
and barley?
Grain as in wheat, barley. Yes, exactly.
Okay.
Okay,
we're talking beer then.
Yes, could be. Yes. Oh, I should have gone one step further. Future beer production.
Okay.
We'll do that. Okay. Future beer production is my link. Okay, so my logic is as follows. So one area of nanotechnology, as we've mentioned, is nanoparticle production. These are tiny particles, as the name suggests, which typically have a diameter ranging from 1 to 100 nanometers. Again, so that's 0.00001 centimeter, so super small. One type of nanoparticle is silver, also known as AgNP. So Ag meaning coming from the Latin argentum for silver, and then NP just meaning nanoparticle. So basically silver particles that are less than 0.00001 centimeters. Now, several studies have shown that nanoparticles, including silver, so silver nanoparticles, they can be detrimental to microbial communities in the environment. And so they can kill bacteria, many of which play vital roles in our ecosystems. However, one recent study showed that nanoparticles can actually kill earthworms as well. And one way they do this is by initiating what's called apoptosis. So this is often referred to as programmed cell death, and is a highly regulated process of cellular self-destruction, essentially cells killing themselves. And it plays a crucial role in biological processes. But if it happens too many times, then the organism can actually die. These silver nanoparticles initiate apoptosis in earthworms. So it seems that nanoparticle pollution in the environment is detrimental to earthworms and various other forms of life. But importantly, a study, I think in Nature or Nature Communications, said that if the humble earthworm were a country, they'd be the fourth largest grain producer, as much as Russia. Yeah. Does that make sense? If not, I will explain it now. So basically, yes. So earthworms, through their activity in the soil, so things like breaking down organic matter and aerating these soils, they increase fertility and make nutrients available for plants and other organisms. And so through this activity, just the earthworm alone, well, there's various species, but they are responsible for 6.5% of global food production, or 140 million tons of rice, maize, wheat, and barley. That is insane, right? So if we continue to pollute the environment with nanoparticles, this could eventually have a major impact on earthworm populations, and therefore on grain production, and therefore on beer production.
Yeah, on the barley, but for the rice, sake would go down as well, wouldn't it?
Sake, yeah, exactly.
Yeah.
What do you think?
And whiskey for the
wheat
grain.
Beer.
Yeah.
Wheat beer as well. So lots of alcohol.
So just so I can understand that properly again.
Yes.
What you're saying is the earthworms. So in other words, because the earthworms are burrowing through and they're, eating the soil and
recycling organic matter.
Yeah. Yep. And they're also providing because of their burrowing, they're actually providing, air pockets and keeping it nice.
Air pockets, water pockets. Yep.
So without earthworms, the productivity of our our grown crops would go down. Is that right?
Exactly.
It's got nothing to do with the microbes. It's got to do with the physical action of the
Not to do with the microbes. Well, yeah, somewhat to do with the microbes, but
the microbes in the earthworm, yes.
Yeah, so so earthworm casts as well. So the kind of the thing that's left behind is also a hotbed for microorganisms that are important in things like organic matter decomposition. So basically, this paper suggested that I thought this was a cool way of looking at it. So if the humble earthworms were a country, they'd be the fourth largest grain producer, as much as Russia. So 140 million tons of rice, maize, wheat, and barley they're responsible for, or 6.5% of global grain production.
Wow.
Yes. But
I mean,
importantly, nanoparticles have been shown, in particular silver, has been shown to cause apoptosis, which is this programmed cell death. And if this happens too many times, the earthworm obviously dies. So if we're continuing to use these nanoparticles in our everyday products, including medicines, health, beauty products, electronics, all sorts of these things. And I reckon they're also using pesticides as well. This is interesting, right? And fertilizers, sorry. So farmers are spraying their fields to increase productivity in their foods, but actually if these chemicals contain nanoparticles, they could actually be killing off bacteria that are really important, killing off earthworms that are really important for food production. So if you think of it that way, it's incredibly counterproductive.
I was looking at a YouTube channel, and like most YouTube channels, they're always sponsored, so they're kind of going, and now a word from our sponsor halfway through.
Yeah, I'm sponsored by earthworms.
Or future beer production.
That's it. Sake.
But it was actually trying to sell sheets which were impregnated with silver nanoparticles for precisely that reason. And I was thinking about it actually, for being antimicrobial. And so I didn't know, is that bad that we live in a microbial bed when we're sleeping? I think we're back to that earlier about all microbes are bad, and
exactly. This is the point, isn't it? So, like, washing machines are often lined with these silver nanoparticles because it supposedly kills, microbes.
99%.
And it does kill microbes. Yeah. There's also some studies linking silver nanoparticles to the spread of antibiotic resistance genes as well. And so this occurs basically, the silver nanoparticles interact with the bacteria and then it initiates what's called an SOS response in the bacteria, so a save our souls response. And this makes it more likely the bacteria will A, kind of eject its own genetic material into the environment, but B, bring in genetic material from other bacteria as well. So this is what's called horizontal gene transfer. But by transferring these genes horizontally between individual bacterium, you can actually spread what's called these antibiotic resistance genes as well. So this can actually have an impact on the whole, antimicrobial resistance issue in the world at the minute. So there are lots of things to consider when we're thinking about nanoparticles getting out into the environment.
I would love to learn more about this horizontal genetic transfer that we know.
And that's not sci-fi. That is actually a thing that's happening.
Yeah. But let's do an episode on that at some point in the near future, because
there's three different methods of kind of horizontal gene transfer as well. So there'll be lots to talk about.
All right. Very awesome. Okay. Well, look, Jake, that is very important to know about that linkage.
Yes,
sake,
particularly
beer.
because of beer and sake. Yeah. Yes. Okay.
That's right.
Thanks.
I'm going to give that I'll give it an 8.9.
Oof. That's not bad, that, is it?
Yeah.
Not as good as the vulture, but better than what was the last one I did? Anyway, thanks. I appreciate that. Did you know that 59% of the planet's species live in the soil, and we get 95% of our food from soil? So soil is important.
I just, on a little side note for that, I'm not sure what your opinion is of SpaceX and Elon Musk's attempt to go to Mars. But I was giggling quite a bit at someone who was trying to point out just how the science was not the way they were explaining. Elon Musk was explaining the science was completely wrong. And in particular, the person was saying, that somehow they thought that they could grow food on Mars and it could become a sustainable lifestyle. And they said, yeah, you can't. And the main reason is because there's no microbes. That can live in the soil, and that's fundamental for plant growth. And no earthworms, no microbes, and so basically, and not enough of the raw materials that actually needs to be in our normal soil, for that growth to occur.
I mean, you'd take some kind of synthetic approach or some kind of
do a hydroponic thing.
Hydroponics, but you'd have to constantly be inputting.
But after a while, lettuce
nutrients
just
and microbes
doesn't cut it for you when you've had it for the 250th day in a row.
Kohlrabi, maybe. Yeah, exactly.
That's right. So
cool.
Yeah. Okay. Look, I think it's pretty amazing. Okay, Jake.
Yes.
What's coming down on the telex from the invisible world?
Okay, so news from the invisible world this week is all about a biodiversity intervention. So it's about children, a biodiversity intervention, and horses. Let me explain further. So there's one study that came out this month, I think, and it's titled, "A 15-day biodiversity intervention with horses in a farm system leads to the acquisition of health-promoting features in the gut microbiome of 10 urban Italian children." That's a title. So the abstract, in order to evaluate the possibility to shape the human gut microbiome through the interaction with the natural ecosystems, they explored the impact of a 15-day biodiversity intervention with horses on the gut microbiome of urban living Italian children. So the children's gut microbiome was metagenomically assessed. So this basically means they sequenced the DNA before and after a 10-hour per day daily interaction with horses in an educational farm. The horse's skin, oral, and fecal microbiomes were similarly assessed, and they found that the interaction with horses facilitated the acquisition of health-promoting features in the children's gut microbiome, such as higher microbial diversity in their gut microbiomes, an enhanced production of what's called butyrate, and this is a short-chain fatty acid. So butyrate's really important in things like allowing our cells to communicate. It's also implicated in favorable mental health and reducing inflammation in the body. So they found that after this intervention, there was an enhanced production of butyrate, and also the increase of several health-promoting species generally considered to be next-generation probiotics. There we go.
How?
So spending time with horses transfers microbes into the children's guts that are actually health-promoting.
So help me out here. Does that work? Do the horses do an oral examination and put their hooves into the mouth? Or how does that work? How do you think it works?
Let's have a look at the methods. Well, I haven't looked at the methods, but I assume they've just been, doing what they normally would do around horses. So just riding them, cleaning them, stroking them, whatever. Right. You're just being generally around the horse environment. And it seems that there are these health-promoting microbes in that environment that then colonize the children's bodies, manage to somehow colonize their gut, which is quite difficult. But
I was going to say, at some point they'd have to ingest it, I assume. It'd have to be ingested, wouldn't it?
Yeah, ingested for sure, yeah. So ingested, but they're omnipresent, aren't they? They're everywhere. So you're constantly inhaling and ingesting things all the time.
Yeah.
But it seems that they've colonized the gut and then increased butyrate production, which, as I said, is implicated in things like reducing inflammation in the body and favorable mental health.
Yeah. So I've got that part. I'm just wondering how it gets to the gut. I can understand if you inhale it, surely that's going to go at most of the circulatory system if it goes across your lungs.
Yeah.
But how does it go from your circulatory system into your gut, into your actual gut microbiome?
So it's probably down the other hole,
right,
as it were. So microbes can also move down the esophagus into the gut as well.
Yeah, I'm assuming that what's happening is they're stroking the horses and then they're accidentally putting their hands close to their mouth or
exactly.
just doing whatever.
Saliva goes down, swallowing the saliva, which is covering the microbes.
Right, yes. So in other words, you're breathing it in, but it's in your mouth and you swallow your saliva and then,
also you're being coated by it as well. So it's probably changing your gut microbiome to some extent, although it's quite difficult to colonize the gut. Your skin microbiome as well, simply by just being basically coated in microbes from the environment. And also your respiratory microbiome by breathing it in.
Amazing.
And there's recently been found to be like we've mentioned the gut-brain axis, there's a gut-lung axis as well. So the lung and the gut can interact with each other through a bidirectional sort of communication system. So that's interesting, isn't it? Yeah. So again, everything is connected. I'd probably say that at the end of this section on every show, but pretty interesting, right? So spend time in nature. This study suggests particularly spend time around horses. Have you ever ridden a horse?
I have.
How'd it go?
Very badly. I was put onto these. My grandmother's next door neighbor was a Prussian horse trainer, and had horses, loved horses, blah 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 blah. And I said, I'm really love animals, etc. etc. So I do feel like I get on really well with animals. So I'm normally great with dogs and cats and stuff like that, and I'm great with cows and horses. But as soon as I got onto the horse just said, and just going, now this mare.
How would you feel?
Yeah, exactly.
I love humans. Jump on one. Get off me. Yeah.
But he basically said, she's so docile, there's no problem and all that. And then after I got thrown, God knows how many times, and you just said,
wasn't docile. Yeah.
She's saying, I've never done that before. So I think that, when we go on long treks, horses and I, it's going to be me next to the horse or me carrying the horse, one or the other.
Okay. No buckaroo action.
No buckaroo action. Yeah. And I do feel always a bit sad now when I see, maybe it's just me but when I do see people riding on horses, I'm always thinking like, I'm sure they were not built to carry humans, but have you ridden horses?
A few times, yeah. I enjoyed it. But yeah, again, I don't really like exploiting animals, but yeah, it's just me being a snowflake or whatever.
Yeah.
But perhaps I need to ride them more because it's good for your gut microbiome.
There you go.
I wonder if it has an opposite effect there. I wonder if our microbes, what effect they have on the horses.
Yes.
That should be explored. It's not all about humans, is it?
No, you're right. You're right. That's a nice flip. Yeah, because it could be bad for them, couldn't it?
Could be. Yeah, exactly. More research needed. Anything else you want to talk about before we wrap up this show?
Not today. I think my head's blown again.
Cool. I don't think I have anything to talk about. Again, we're just excited to present the next episode to you in a couple of weeks. And thanks a lot for tuning in to Interconnected. See you again.
Okay. Bye.